Hi students, this is Maheshwar Reddy. In this class, I am going to deal about embedded processor and their types. See, what are different types of embedded processors we are using for application development and the types are discussed here. Here, embedded processor means it is a main processing element which is used for application development. Almost 80% of the embedded systems are processor or controller based. We know that. It may be processor or controller based. The processor may be microcontroller or a microprocessor or digital signal processor or application specific IC. It depends upon the domain and application. See, most of the embedded systems in industrial control and monitoring applications make use of commonly available microprocessors and microcontrollers, whereas domains which require signal processing such as speech coding, speech recognition, etc. makes use of special kind of digital signal processors supplied by manufacturers like Analog Devices, Texas Instruments, etc. And here, embedded systems, we know that embedded systems are application and domain specific. See here, embedded systems are domain and application specific and are built around a central core. This central core is your processor. The core of the embedded systems falls into following categories. See, these are all the embedded processors we are using for application development. The first one is microprocessor, second one microcontroller, next digital signal processor, next application specific IC, ASIC, next complex programmable logic devices, CPLDs, next field programmable gate arrays, FPGAs. That means for embedded system application development, for processing element may be microprocessor or microcontroller or digital signal processor, or it may be application specific IC, or it may be complex programmable logic device CPLD or field programmable gate array. Let us see each one in detail. First, microprocessor. A microprocessor is a silicon chip, represents a central processing unit. What does it contain? The microprocessor contains central processing unit as well as arithmetic and logic units and a predefined set of registers and instructions. And we know that microprocessor is a dependent unit. Microprocessor is a dependent unit. That means it requires the combination of other hardware like memory, timers, interrupt controllers, I/O ports, etc. Without interfacing external devices, microprocessor does not work. Understand? And microprocessors are used in general purpose applications. Next, microcontroller. You know that microcontroller is an integrated chip that contains CPU, data and program memory and data memory. That means RAM and ROM, special and general purpose registers, timers, interrupt control unit, and dedicated I/O ports, and some inbuilt peripherals, etc. Since a microcontroller contains all the necessary functional blocks for independent working, these microcontrollers are mostly used in the embedded domain because all are integrated internally. Microcontrollers are application oriented and used in domain specific applications. Where they are used in domain specific applications. Next DSP, digital signal processors. These digital signal processors are mainly used in embedded applications which needed audio, video and signal processing and in communication applications. Where they are used in audio, video, signal processing and communication applications. This DSPs, digital signal process, implement algorithms in hardware which speeds up the execution, whereas general purpose process implement the algorithm in software, and the speed of execution depends primarily on the clock of each processor. This DSP process uses real-time calculations like FFT, as we studied in DSP subject, FFT, fast Fourier transforms, DFT, discrete Fourier transforms, convolutions, sum of products calculation, etc. These are mainly used for audio, video, signal processing, telecommunication, multimedia applications. And these are some of the examples related to DSP. Next, ASIC, application specific IC. See, this application specific IC is a microchip designed to perform a specific or unique application. Specific or unique application means specific, it is performs only, or it is used for specific application only. For example, calculator. If an IC is designed for calculator, it is used for calculator only. We cannot place that calculator IC in another device. And for example, if you design an IC for washing machine, it should be used for washing machine only. That ASIC, the application specific IC, should be used for washing machine only. You should not place that IC in another device such as tape recorders or ACs, etc. It is used in specific or unique application only. It integrates several functions into a single chip, thereby reduces the system development cost. This is the main use of ASIC. ASIC reduces the system development cost. As a single chip, ASIC consumes very small area, so we can design smaller systems with high capabilities. Next, CPLDs and FPGAs. Complex programmable logic devices and field programmable gate arrays. The PLDs consist of a large number of programmable gates on a VLSI chip. These programmable logic devices consist of a large number of programmable gates on a VLSI chip. With programmable logic devices like CPLDs and FPGAs, the designs can be quickly simulated, tested, and programmed into the devices. And the CPLDs and FPGAs are mainly used in network routers, DSL modems, and automotive navigation systems, etc. And these are the different types of embedded process we are using for building embedded applications. That means among the following processing elements, you can use any one for building embedded application. Thank you.